Assalamualaikum and hi everyone. I'm Tasiran Surini Abdul Rahman. This video is for BEJ40401 student. Today I will be explaining about lab number 5 part 2, which is on digital to analog conversion, or in short DAC, in LPC1768 microcontroller. So this is the outcomes of lab 05. In the previous lab, we already done the analog to digital conversion, or in short ADC, in which we convert the analog value to the digital form. So today we try to configure, apply and debug the DAC for LPC1768 in Kill software. If you refer to the user manual, this is the location for digital to analog converter, or DAC, in LPC1768 memory map. This is DAC block diagram, whereby DAC converts a digital number represented by D into analog output represented by V0. So DAC uses voltage reference to calculate the V0. This is the formula to calculate the analog output V0, whereby V0 equal to digital number divided by 2 to the power of n multiplied by voltage reference, which is VR. So n here is number of resolution. LPC1768 has a 10-bit resolution. So here is 2 to the power of 10, which is equal to 1024. So for example, if we have 500 digital number, then we divide by 1024 and multiply by the voltage reference, which is 3.3 volt. So we will get 1.61 volt. Another example, if we have 700 digital number, then we divide by 1024 and multiply by 3.3 volt, we will get 2.25 volt. So 700 digital number equivalent to 2.25 volt. Okay, so this is the pin diagram for DAC in LPC1768, whereby we only can use port 0 pin 26 for DAC. Okay, this one is analog output. Okay, unlike ADC that has, or that can use 8 pins, GPIO pins, but for DAC port we only can use port 0 pin 26 for analog output. This is the program on how to develop a DAC in LPC1768. Okay, the first instruction is LPC pin con pin cell 1. So we use pin cell 1 register, and then we need to give bit 1 to pin 21 to set GPIO port 0 pin 26 as analog output. Okay, so we have to, if we refer to user manual, analog output only function when 1 0. So what is the pin involved? We need to refer to the first column. Okay, so this is the column at the same row of A out. Okay, analog output. So the pin involved is pin 21 and pin 20. So we need to make sure that the left pin here must be 1, because here is 1. Okay, here is 1. So that's why in our program we need to give 1 to pin 21 to set up port 0 pin 26 as analog output port. Okay, the second instruction is we declare a variable name to assign the digital form here, the digital number here. Okay, you can use any variable name as long as it is a legal variable name. Okay, so here I use value as our variable name to hold the value of digital here, digital number here. Okay, so while 1 here means compiler will always repeat this instruction within open bracket and close bracket here. Okay, so let's say I have value equal to 500. The digital number is 500 and I want to convert this 500 into analog value. Okay, so the result of this conversion will be saved at here, DAC register. Okay, so we need to shift to the left 6 times. Okay, why 6 times? This one we need to refer to the user manual, DACR. Okay, so this is the DACR. So we need to in table 539 we need to save the conversion value in pin 6 until 15. Okay, so pin 6 until 15. So we can imagine that this is the DACR. So pin 6 until pin 15 is the pin to save the result of conversion. Okay, so that's why in this instruction we need to shift the value, the result, to the left 6 times, because we want to make sure that our result is in, our first number is in pin 6 here. Okay, 1 2 3 4 5 6. Okay, 1 2 3 4 5 6. Okay, all right. So and then we have some delay here. Okay, now I want to try to build the program here. Okay, I press the button build and then I debug, and since there is no error here, and then I go to peripheral and I choose DAC converter. Okay, DAC converter, and then I press button run. Okay, and I can see that 500 in decimal is equivalent to 1F4 in hexadecimal. So this is the value in digital form, and this is the value of conversion. This is the result. Okay, so the result here is in voltage, which is 1.61. So we get the same result as what we calculated previously. Okay, all right. So this is on how to convert the DAC. Okay, we can try to convert another value, for example 700. Okay, and then every time we change the value we need to stop the run and then stop the debug, and then you have to reboot your program. Okay, then try to debug and try to run. Okay, so 700 in hexadecimal is 2 BC, and then we will get 2.25 volt. Okay, so in simulation we also get 2 BC. Okay, this one 700 means in decimal equivalent to 0.2 BC in hexa, and then we get the same result as what we calculated previously, which is 2.2. Okay, 2.25 volt. Okay, all right. So let's say we want to convert two value at the same time, so we can just copy this value. Okay, for example, we want to convert the value 500 and also 700. So we can do so. Okay, we can do both, and then we can stop running. Okay, and then stop debug and then try to reboot. Okay, and then you can try to run, and you can see that you can try to run, and then you can see that your program, your conversion value here alternate with 500 and 700. Okay, it should be like that. Okay, that's all my explanation for DAC conversion. Okay, for your task, what you need to do is you have to submit me lab assignment 2. You have to prepare the video and you have to make sure that you appear in your video. Okay, in lab assignment 2, what you need to do is you have to develop a DAC program. Okay, and the display of waveform should be this waveform, so to waveform. Okay, so I just give you the example here. So this is the example of display output. Okay, you have to go to the view analysis windows and logic analyzer. Okay, and for the setup you have to type A out, okay, for the waveform here, and then the display type is analog. Okay, what you need to do is you have to put a continuous value. Okay, so you have to use any repetition instruction. For example, I use 4 and then I put a minimum value, which is usually we put as 0. Okay, and then I put the step size here. Okay, and which is the increment, and then I need to give a maximum value here. Okay, I need to give a maximum value here. Okay, this one is the maximum value. So in instruction I need to give a maximum value. Okay, this is the minimum value or starting value, and then we need to give a increment value, and then we need to give a maximum value. So hopefully you can answer the lab assignment 2 and submit the video to me through Otter platform. Okay, thank you everyone, that's all.